Okay, so welcome everybody. This is the Bridges-2 webinar. Just a few housekeeping notes as we get started. We're recording this. The webinar will be on YouTube for those who can't make it, or for you to refer back to. Of course, we'll be happy to make the slides available to everyone here and beyond. Our format today is about 40 minutes of presentation, followed by Q&A. So please hold your questions verbally. We have a Slido link here where you could submit questions. It's also really nice because you can upvote questions if they've already been asked to avoid redundancy. And we'll be seeding the Q&A at the end of the webinar with the questions that come in through Slido or possibly through Zoom chat. We'll be issuing a few Zoom polls throughout the webinar just to get your input on some thoughts that come up during the presentations. So I hope you hear what you're looking for. Please ask questions, participate, interact, and we'll move forward. So the presentations by myself, I'm Nick Nystrom. I'm Chief Scientist at PSC. I'm PI and Project Director for Bridges-2. And the Bridges-2 co-PIs, Paula Buitrago, who is also the Director of AI and Data Science for the project and at the center, Sergio Stanulevich, who's the Director for User Support on Bridges-2, Robin Seebeck, who is Director for Broader Impacts, and Ken Hackworth, who is our Allocations Manager for the all-important aspects of getting on the system. So I'm going to move fairly quickly. We have a lot to cover. The outline is a quick introduction, then moving into Bridges-2, and what's it for? It's for research and education, but why is it good? Why did we design it like we did? And what is it that you can use for your own research? We'll talk a little bit about the early user program, so how to get on Bridges-2 prior to production, how to get allocations both then and beyond, and then a wrap up. First, I want to acknowledge the National Science Foundation, the sponsor for Bridges-2. To date, there's $12 million that have been awarded. That covers the acquisition and early operations. This will be a 5-year project. And the whole point, the title is Scalable Converged Computing Data Analytics for Rapidly Evolving Science and Engineering Research. So we'll go back to what that means, what we mean by rapidly evolving. Hewlett-Packard Enterprise is delivering the Bridges-2 system. They've been a great partner through this, and we're working with them as we all deal with COVID-19. The last thing I want to say here is that Bridges-2 will be deployed later this summer. And because of that, it's not here yet. That means some things here are subject to change, and they may in fact get better. So sorry about that, my mouse is running wild. I have a few links here, and this is to learn more and to participate. So first of all, we have the Bridges-2 website. Watch this page, it's being populated as we speak. And this is where you can find out more information as we move forward throughout the spring and summer. There are 2 forms. There's a software request form and a dataset request form. These either are live or will be live imminently. And this is so you can tell us what software you would like to have installed for the start of the early user program. And the same way for community data sets. If there's data that you require, especially where other people are also using it heavily, we'd like to know that so we can have that in place for you. The Exceed user portal we'll come back to in the allocations section of this talk. That's how you actually get onto the system, both early user and beyond. And we will have, as of June 1st, a new email address, bridges2@psc.edu, for writing to us for other questions you may have and input and requests. So I'll move quickly to what is Bridges-2 for? Why did we design it like we did? So when NSF was designing their portfolio of cyber infrastructure, they were looking for this round at rapidly evolving science and engineering research. And we've been doing a lot of that with Bridges-1. But we thought hard about it, and for Bridges-2, we see that meaning several things. First of all, absolutely, we are keeping high performance computing and high throughput computing for simulation modeling. That continues to be essential. It also means, though, high performance artificial intelligence and AI enhanced simulation and modeling. This is really important because this is cross-cutting research across the physical sciences, life sciences, engineering, social sciences. And this is one area that is really rapidly evolving. It's one area where we pioneered a lot with Bridges, and we're continuing that in Bridges-2. In fact, we plan to federate Bridges AI with Bridges-2 to add more capability in that area. Community data and big data as a service continues to be massively important. This is a way of democratizing research for making large data sets available with the advanced computing and with the software tools to work with them. So that domain specialists can use community data without having to be computer science experts, data wranglers, or have the expertise that we used to associate with high performance computing. Like Bridges-1, we maintain high ease of use, familiar software, really emphasize interactivity to get things done while people think, and productivity. We welcome your thoughts on how to make it even easier to use and how to make it better. And then the fifth area here is really integrating high performance computing, artificial intelligence, and data, and building complex workflows, leveraging heterogeneous computing, and interfacing with other clouds. So all these together really give us a foundation for supporting rapidly evolving science. And some examples of what that means are on this next slide. So these are just some areas of many, many more where Bridges-2 will have a huge impact. They are things like looking at gene expression. This would leverage large memory and really being able to work with genomic bioinformatic information at scale. Visual pathology, this is actually from work with collaborators of ours that won the HPC Wire Best Use of HPC in the Life Sciences last year at supercomputing. And this is a look at very large scale imaging, very deep AI on extremely large 100,000 by 100,000 pixel images. So really pushing the limits, requiring a lot of GPUs per node, a lot of GPU memory per node, really at scalability. HubMap is a program that we're leading at PSC on developing an atlas of the human body at single cell resolution. So this is really a great example of big data as a service where we will have vast genomic, proteomic, and imaging data on human tissue with the tools to work with it at the same place, eliminating data movement and all of those things. Integrating with things like smart cities and AI at the edge. Working with very large scale physics. This is with Fermilab on the CMS detector. Again, employing machine learning to look at events. Recognizing severe weather features. Again, in this case, integrating simulation and advanced AI. Immunity. This figure was actually predating our current challenges with COVID-19. But this is immensely important right now, and there are a lot of new results coming out. And then developing brand new materials with great properties for energy production, catalysis. These are all examples of things that we're making possible with this idea of rapidly evolving computing. And so what I'll cover now is just very quickly what all that means. So with Bridges, we had a system, we designed a network. It was OmniPath in that case. We brought together high performance computing, AI, and data resources under one fabric. So you could use it all together, go back and forth between different modalities. And it has been a great success. It continues to be. It's had over 2,100 projects, over 20,000 users, 800 institutions, but most significantly, 121 fields of study. So this has enabled not just the traditional HPC, but also fields like biology, neuroscience, economics. People who have never used high performance computing before. And when I produced this table, it had 130 active education allocations. With Bridges-2, we're taking all of that to the next level. We're making it better. We're adding new features. The things we're adding that are new are really full system, high performance artificial intelligence. We'll go into that. There's a fast flash array for extremely fast data access, especially for things like deep learning training and genomics. HDR 200 megabit per second InfiniBand throughout, with multiple links between the AI nodes for scalability. A tiered data management system, so there will be a backup for resilience to tape under a single namespace, and then enhanced cloud interoperability. The high-level cartoon of what the system looks like is here. Like Bridges-1, there's a central interconnect that brings everything together at full speed. This, in this case, as I said, is now Mellanox HDR 200. It doubles the bandwidth. That connects everything. It connects to compute nodes, regular memory, large memory, extreme memory, and GPU nodes. They're down here in green. Various utility nodes for web servers, databases, data transfer, and logins. Significantly, these are dedicated nodes for standing up things like web portals, doing distributed services, and science gateways, having persistent 24/7 databases for doing advanced data management, and really being able to drive these interconnected data and computing ecosystems. Also on the fabric are the data storage infrastructure. So there's a parallel file system. That's 15 petabytes usable, very high bandwidth. So 129 gigabytes per second read, 142 gigabytes per second write. That's Lustre. That then goes with the HPE Data Management Framework, DMF, which provides a single namespace, rule-based, very easy to use for users and PSC administrators to a tape backup. And assuming about 20% compression, which is what we've seen in the past, and that's in hardware, so it's at line speed, about 8.6 petabytes there. Now that's expandable. So if given projects come along, they say they would like to have another multiple petabytes for data archive, we can do that. There's also this flash array. The numbers here are actually lower bounds. It will have 9 million IOPS, 100 gigabytes per second. The capacity I actually expect to be a lot higher than 100 terabytes. And so then that goes out through high performance networks to exceed campuses, instruments, and so on. The core concepts of Bridges-2, and if you're watching your screens, you're getting these Zoom surveys popping up, please respond. We'd love your feedback. We'd love to know what people are using, what they want to use. And I think we'll be able to show these survey results toward the end. So you can see what your collaborators are thinking. So the real point Bridges-2, it builds on the concepts we pioneer with Bridges-1, and it extends and enhances them. So everything we did before, we continue, the good, at least all the good things. Converged HPC AI and data, a custom fat tree close topology, which provides the most cost-effective way for getting high bandwidth HPC at moderate scales. This complements machines like Frontera, and it provides really unique capability. Having heterogeneous node types, you can combine different kinds of nodes in workflows. Having a GPU sector that is really built for AI from the ground up. This is designed to be stronger than what people generally have in their research clusters. Having multiple tiers of memory, an extremely flexible software environment, and focusing on community data. Now, where we go beyond Bridges is upgrades of everything, obviously. So the CPUs are now really the most powerful CPUs in this time frame. They're AMD EPYC Rome 7742 CPUs. I'll go back into these in more detail. But they're 64 core, they're really monsters. That means 128 cores per node, 8 memory channels each. AI scaling to all 192 V100 32 gigabyte GPUs. What SXM2 here means, for those who aren't familiar with that, is these are interconnected within the box. using NVLink 2.0 at really fully interconnected at maximum bandwidth. And then the two HDR200 links between each of these is really designed to scale AI training up. The flash array will accelerate all of this. It's a very high performance pool for having large training data, especially. The Mellanox InfiniBand network is not only double the bandwidth, it also provides, let me back up a slide. Why can't I back up a slide? I don't know. It provides GPU direct between all the GPU nodes, and that's what allows better scaling. It also contains SRIOV, so being able to do containers and virtual machines across nodes. The storage system is now the HPE Cray Cluster Store E1000. When HPE acquired Cray last fall, that brought this great piece of storage hardware into what we could capture. And so we'll get into a little bit more detail on that. And then DMF for managing the namespace. I just wanted to circle back to flexibility and ease of use. We did take into account all the questions we received prior to the webinar, both through the registration form and Slido. The first key here is interactivity. On Bridges-1, which people can get to right now if you want to get going, you just type interact. It will put you on the node and you can do what you need to do without waiting for a batch system. We support all the popular languages and frameworks: Python, Anaconda, R, MATLAB, Java, Spark, Hadoop, Julia, you name it. And so certainly you can still do C++, Fortran, MPI, those are fully supported, but as well as all of these things are being used very heavily today. All of the AI frameworks you would expect, especially through the NVIDIA GPU cloud containers, but also that can just be built. For containers, we support Singularity. I expect us to also be supporting Docker through lightweight VMs for isolation over time. And we're also looking at schedulers like Kubernetes to help with orchestration. As I mentioned before, we have databases. So if you need to have persistent databases, be they relational, graph, document, you name it, we have nodes for that. Some nodes have SSDs, some nodes have hard disks for capacity. But the point is being able to have those for applications that need to always have a database connection. The gateways, science gateways, and web portals rely on that. There are nodes for that as well. And then having a really large collection of applications and libraries for those who need it. I'm going to go super quick through these. These are mainly for your information on the node types. So the regular and large memory nodes with 256 and 512 gigabytes of RAM each. These are what feature, along with other nodes, these feature these new AMD EPYC 77 Rome CPUs. And these are really, they are the best of breed right now. They let us get higher performance on this system in this time frame than we could have any other way. They all have in-node NVMe SSD for very high performance data caching and scratch. They all have 200 gigabits per second networking coming out. There are also a set of HPE nodes for doing large memory. Now these are based on Intel Cascade Lake CPUs, because here we want to have 4 CPUs per node, and that's something the Intel CPUs do give us. So here these are advantageous. They have 4 terabytes of RAM. It's almost as fast. On the regular memory nodes, these are DDR3200. And on the large memory, they're DDR4 2933. But it is all RAM. These would be the platforms of choice for things like genome sequence assembly, large-scale graph analytics, some quantum chemistry, other codes that don't really go well on MPI. These also have more onboard SSDs, more of it, and also Mellanox 200 gigabit per second InfiniBand. And then the GPU nodes are HPE Apollo 6500s, and these each contain 8 V100s maximum memory and fully NVLink connected. So it's designed to trivially scale up to 8 GPUs for training and also going across nodes with frameworks like Horvath and others, up to the full 192 GPUs. And that's why we put the 2 Mellanox connectors in each of these to max out that bandwidth. These all have 512 gigabytes of RAM, and this is the current plan of record. Moving forward, I'd like to hand it over to Paula Buitrago, who is the Director of AI and Data Science for Bridges-2.
Thank you, Nick. Can you hear me well?
Yes.
Good. So I will describe Bridges-2 artificial intelligence approach at a high level. As we are all aware, science and engineering have been adopting artificial intelligence and increased the adoption over the past years. The Artificial Intelligence Index, which is an annual report prepared by Stanford, clearly displays how publications, class enrollment, conference attendance, and investment in AI has just grow and grow since 2012. With Bridges-2, we will continue our mission to converge HPC AI and big data. Now, the great results of milestones conquered by AI have been tightly coupled with computation. This graph that we have on this slide shows how OpenAI identified 2 eras of AI with regards to computation. Prior to 2012, we can see the initial line to the left. So the computation required for the largest AI training was tightly coupled with Moore's law. So computation was increasing about twice every year. After 2012, the compute needs had been doubling every 3.4 months. That means that since 2012, the computing needs have grown by more than 300,000 times. So it is clear that advancing AI and continue advancing AI requires offering more compute power and simplifying the development process. Now, next slide, please. Ever-growing models and iterative approaches are partially responsible for the high compute demand. On the right, we can visualize the progression of models for image classification. And on the table on the left, top left, we can see some of the networks in the past year that are used for machine translation, question answering, and other natural language processing tasks. The number of parameters of state-of-the-art models has grown from a few millions, as you can see on the right, to hundreds of millions, and more recently billions of them, with Megatron LM having 8.3 billions of parameters. Now, combined with these gigantic models, we have the fact that machine learning approach usually involve iterative paradigms. So we have items like reinforcement learning, generative adversarial networks, and domain adaptation that combine these big models and require iterative training of them. Next slide. In response to the AI community needs, Bridges-2 will have a 3-winged approach for AI and data. Each of these approaches will be defined by a big concept like productivity, usability, and interoperability. In terms of productivity and adjusting to the needs of non-traditional AI users, we will offer outstanding AI compute and data capabilities as described by Nick, and we will support the use of multimodal data in a single system. We will continue to reinforce our community datasets approach, offering on Bridges machine learning datasets that are popular in the field, and also datasets requested by users. For this, you can use the form that Nick described at the beginning of this webinar. These datasets will be coupled with the necessary tools to properly manage and process them. Next slide. As mentioned earlier by Nick, Bridges-2 will feature also InfiniBand, which will allow GPU remote direct memory access communication between GPUs without going through CPUs. This will greatly enhance the ability to communicate across GPU nodes. As of now, this is something we cannot do in Bridges-1 with Omnipath, and makes Bridges-2 a way more powerful AI machine and differentiates it from most public clouds. Next slide. In terms of data infrastructure, Bridges-2 will offer 3 tiers of storage that spans needs from very fast access to disaster recovery. The large flash array with 100 terabytes will allow training on much larger data sets. Just to have a point of reference, the current DGX2 that we offer on Bridges-1 has only 30 terabytes of storage in flash. This large flash array will also allow large graph analytics and certain data-intensive genomic workflows. DMF's single namespace will also be a big win for users, and it will save us from having to invent and manage a way to migrate to and from tape. All of these data components are scalable, as Nick mentioned, and can be grown, including adding tape for specific funded projects. Next slide. All in all, Bridges will be able to function as a big AI engine. We will focus on enabling users to run AI at scale where pertinent. This is a big focus for Bridges-2. This means we will make sure necessary tools are available. We will offer training and offer specialized user support and monitoring tools where needed to be able to have our AI users transition into large scale deployments. Next slide. In terms of usability, Bridges-2 will continue to offer a rich ecosystem of popular and friendly data science tools. We will include most popular machine learning frameworks, as well as Jupyter notebooks offered through on-demand, Java, containers, MATLAB, R, and alike. Recognizing also that training and inferences are just a couple steps in the complex machine learning development workflow, we will be evaluating and incorporating tools for machine learning workflow management, such as MLflow and MLrun. Next slide. As we all know, artificial intelligence is a very rich field with more and more domains incorporating it. So having a system that is interoperable is a must. With its advanced networking capabilities, Bridges-2 will enable tight integration with large data projects, such as the Brain Image Library and the Human Biomolecular Atlas, as well as cloud providers, other cyber infrastructure, and the cloud in general. Next, we will have Sergio tell us about the coming early user program and how to get ready for Bridges-2. Thank you.
Okay, I guess I'm unmuted now. That's good. So yes, the early user program is going to be the opportunity to get to the system early before anyone else, except all the others who are also going to sign up for it. So it'll give you the opportunity to port, tune, and optimize your application early on at no charge. Of course, in terms of dollars, there's never a charge for exceed allocations, but the cycles that you consume during the early user program will not be charged to any other allocation that may follow or that you might have. And then, so you can optimize, you can get your application running, and then hopefully you'll very soon get to, produce actual results and get scientific progress early and again at no charge. You will have the user support system, guide, frontline support, and advanced support ready for you from day one of the early user program. We will have the software and data sets most frequently used on Bridges pre-installed and ready at the beginning from day one of the program. But as I think we've already discussed a bit in the chat, and Nick said up front, we are collecting your specific hardware, software, and data set needs using those forms that you see linked again there. And the request that we received by June 15th will be addressed for the charge for the start of the early user program. So where we see things that we do not already have planned, we will do our best to have them available for the folks who want to use them. And then again, there's this other link that Nick already mentioned, the landing page where we're going to keep you informed of news, including when we launch the opportunity to apply for access. Next slide, please. So Ken Hackworth is going to discuss the allocation access requests at length, but they will be granted based on lightweight proposals. We ask you to submit via XRAS, mainly to tell us what you intend to do and what you hope to achieve uh, during the early user program. And as Ken will discuss, if you already have an Exceed grant, then those will be supplements to your active grant. If you do not yet have an active Exceed grant, they will be startups. And Ken again will discuss what that means in terms of applying for them. In terms of feedback collection, there will be a widget on every page of the user guide for Bridges-2. And we ask you, please use it whenever you have anything you want to communicate to us, whether it's a problem, a question, a comment on any aspect of your experience. And on a weekly basis, we are going to check in with you to ask you about your experience and progress, and using the widget, and also when we ask you, please share insights as to how we can further improve Bridges-2. And after 4 weeks of the early user program, you will be presented with a short survey we will ask you to complete, speaking to your experience and your progress. And again, the important thing is that we really hope that the activities you'll be able to do during the early user program will result in scientific progress for your work. And on to Ken.
Thank you, Sergio. So for the early user period, access to Bridges-2, yes, as Sergio mentioned, we are looking for lightweight requests for new startups or supplements to existing research or startup allocations with a specific scientific goals for the end user, early user program. So these lightweight requests on a startup, if you have an existing startup, if you have an existing research request, you would just request a supplement. We will talk a little bit about that. If you don't have access currently to Bridges or Bridges-2, which you will, you would need to submit a startup allocation, or if you have access through to another Exceed allocated resource, you could request a supplement on that. The request will be using the Exceed allocation submission page. We'll have some updates on this when this is ready for Bridges-2 to be requested there. That'll be on the PSC Bridges-2 website. And again, as Sergio mentioned, there are no charges for the use and access during the end user program or the early user program. Startup, educational campus champion requests. These requests will be available late summer, early fall. Again, we will make these available through the Exceed submission pages. Exceed research requests, or XRAC requests, for the fall 2020 start period. There's a submission window that will be opening June 15th through July 15th for review late in August and project starting in the fall of 2020. This is where you'll be able to request active production research allocations on Bridges-2. And again, 90% of these Bridges-2 will be available through the Exceed program. Next slide, please. So if you're not familiar with the Exceed program, this is where we start for allocations. But first, you'd have to create yourself an Exceed portal account. I would bet many of you do, but if you don't, if you want to have a closer look at this slide, the portal.exceed.org, sign in, create your account. It'll ask you for the information, confirm all of this with verification, and set your username and password. And then you'll be able to start requesting through the submission pages. access in the early user program for Bridges. Next slide, please. Here you'll see that Bridges-2 will be, we use the Exceed user portal, the Exceed resource allocation system, or XRAS as we call it, to receive applications for allocations and access. So you'll see there that you would go, once you have your portal account, go to the allocations pages, and then below that, submit/review request. Here you can request all sorts of allocation requests, startups, campus champions, research, but this is where you'd want to start with a supplement if you already have an allocation on Bridges now, to get a supplement onto Bridges-2 for the early user program, and or if you don't have an allocation, you would submit for a new startup allocation. Next page, please. So there were a few questions that came in early when the registration happened. Will there be any difference in the requirements or procedures for allocation proposals, including startups for Bridges-2? No, as mentioned in the previous slides, both by Sergio and myself, Bridges-2 will be allocated as Bridges-1 has been for the past several years through the Exceed program using the XRS system for allocation submissions. Another question was, how and when should I apply for an allocation on Bridges-2? And what if I am new to PSC? So again, we'll make access to the Bridges-2 resource during the early user program. However, depending on whether a group has a current Exceed allocation on Bridges or another Exceed allocated resource, if so, then a supplement will be proper course of action. If no allocation exists, we recommend initially requesting the startup request through this Exceed submission site. I used to have access to the Bridges part of a Campus Champion allocation. Will Campus Champion allocations automatically transfer to Bridges-2? Bridges-2 will also be welcoming Campus Champion allocations, as we have done for many years on Bridges. There will be a period when allocations will be transferred from Bridges to Bridges-2 in the late summer, fall period time. The other question was, how and when will Bridges allocations be transferred to Bridges-2? Again, PSC will work together with the Exceed RAS team to migrate Bridges allocations to Bridges-2 around the time period of Bridges-2 going into production. So you will hear more from us on this. We will help you work through this. Again, the allocations team is here for you. Ask questions. We're always happy to help and get you science moving along on the Bridges and Bridges-2 resources. Next slide. Thank you, everyone.
Okay, thanks, Sergio, Ken, Paula. So I just want to summarize things very quickly, and then we'll go to questions. We've had a lot come in while we've been meeting. So first, the word's underway. We've already been allocating some projects to Bridges-2 that will be starting on Bridges-1, then migrating into Bridges-2 after Bridges-1 ends. Our next window for extract proposals, as Ken said, is June 15th through July 15th. So if you'd like to write a research proposal for Bridges-2, that's about a month and a half away. And we'll have ways of incorporating performance and scaling documents for those who are familiar with that once we get on in the early user period. We'll be doing delivery, installation, and testing in summer to fall. Someone had asked earlier about whether or not COVID-19 will have an impact, and I think COVID-19 has an impact on everything. So we're working the supply chains and getting that going as fast as we can. We will, once we do the initial testing, we'll have our early user program. That's actually part of acceptance testing. So we'll do that. That will be at least 30 days. And we'll wrap up acceptance testing, then we'll transition into operations. In around the October to November timeframe, that's when we'll transition from Bridges-1 to Bridges-2. So in summary, the things we start with Bridges, for those who have used it, we're going to build on those concepts. We're making them bigger, better, and improving on them, both qualitatively and quantitatively. We're bringing in full system AI, a much more powerful interconnect fabric that doubles bandwidth and introduces things like GPU direct communications, as well as other collectives and other optimizations, an all-flash array for very fast data access, tiered data management for greater data resilience, and enhanced cloud interoperability. Sergio's organization is providing user support, as they've done on all of our other PSC systems, and that includes support through the early operations period and early user period. So I'd encourage everyone here to join us for the early user program. Help us make the system better, give us feedback, and in the process, I hope we can help you get some science done. That will be the real metric of the early user program, is what science does it enable. So that's where I would leave it. I'm just going to put this slide back up once, but I'll leave this there. Again, not all of these links are live today. They will be certainly by Monday, maybe by tomorrow. And I'd like to transition now into questions that have been coming in over the Slido and Zoom chat. I have those on a separate device. If I'm looking down, that's what's going on here. So I will just start going through these, and I expect to farm some of these out to my colleagues. So I'm going to try to go in the order that they've come to me, because otherwise I'll get lost. So first, there were questions about, will Bridges-2 allow non-AI on GPUs? And the answer is yes. It will be both AI and non-AI. And as I said, we have a plan, not yet realized, but a plan to federate Bridges AI with Bridges-2, which will bring in those 88 V100 voltage GPUs as well. There was a question, will we require two-factor authentication, and can science gateways get an exemption? We don't require two-factor authentication now for projects that need it. We, of course, support it. But so I don't expect we'll require it on Bridges-2 either. And if at a point that does become necessary, I'm sure there are ways we could do exemptions, because it is just, it's not needed for everything. It's only needed for certain purposes. There was a question, are there established benchmarks on performance and speed for Bridges-2 compared to Bridges-1? We can publish those over time. What we'd like to do, we of course have a number of benchmark targets and acceptance testing. We'll be happy to share those. And this is a unique system. There's nothing like it in the world. These Rome processors are not even available today. So we will share those benchmarks as we get them. Can we provide tips and other promotional material for campus champions? That's a great question, because it's a great idea. And we'll take that as an action item to develop those materials, because we need those to get the word out to about Bridges-2 to other communities, and definitely that will help campus champions get the word out as well. Do you plan to include Ampere GPUs? That's a great question, and all I can say right now is we are actively looking into that. For applications currently on Bridges specific to lab groups, do they have to be installed on Bridges-2 separately and licensed? And it will be a different system, so the answer to that is yes. Next question, does the IB Interconnect have features for accelerating AI applications, special collectives, etc.? Same for the CPUs. So the Interconnect, absolutely. The Mellanox HDR does have a lot of compute built into the fabric. And so there are things there that will accelerate AI and other applications. The AMD CPUs, nothing AI specific, but their accelerations for doing linear algebra are definitely a big help. And the sheer number of cores means that one can easily allocate some portion of the cores for doing inferencing if one's running a surrogate model, and other cores for doing the heavy lifting of the simulation. So one could imagine having things running concurrently with, say, 48 cores simulation, 16 cores inferencing, or otherwise, whatever the right balance is. So that number of cores gives us a lot of flexibility for that. there was a question on, do cloud providers like AWS play a role in Bridges-2? And I'd like to jump in there and then turn it over perhaps to Paula also. So one thing I'd say is for other big projects we've been doing, like this Human Biomolecular Atlas, our workflows are fully containerized, and we're using a framework called Airflow to orchestrate launching containers between Bridges and Amazon. We certainly expect to do it with Bridges-2 as well. So we expect interoperability with clouds. The cloud providers are not partners in this project, but we will interoperate with them. Are there things to others on the call, so Paula, Sergio, that you might add for your thoughts on cloud?
And Nick, so thank you, Harrison, for that question. It has been answered over the chat, but it's basically what you just described.
Okay. Yeah, one thing I'm getting questions. I'm seeing the feed, but I don't know what came from Zoom or what came from Slido, so I'm not.
It's all good.
Yep, I also didn't see the answers. Sorry for the redundancy. Okay, is there a scheduled date after which Bridges-1 will not be available to exceed users? So the planned completion date for Bridges-1 is November 30th. And we expect that to be that date when it will not be available for compute. That's the plan. What I would say is we also anticipate perhaps leaving parts of Bridges-1 available for doing any data transfers that have not completed prior to November 30th. So if someone had a project they're trying to wrap up and they want to run for most of November, they may want to migrate the data to Bridges-2 or elsewhere. And for that, we expect to leave Bridges-1 up for a while. Okay, can postdocs apply for the early user program? Possibly with no prior record of allocation? Yes. So one thing, that's a really great question, and it makes I want to re-emphasize a point that Sergio and Ken made, and that is, first of all, that access to Bridges-1, Bridges AI, Bridges-2, and other systems funded by NSF like this is completely free of charge. And that's to anyone doing open research where the PI is at a US-based institution. PIs can be faculty, postdocs, research staff, or graduate students with NSF fellowships. So absolutely, it's open to postdocs. And if you have any questions about eligibility, just contact us. Write to us right now at bridges@psc.edu or bridges2@psc.edu in a day or two, or contact me or Ken or others, and we can answer eligibility questions. Okay. Am I missing any questions? So
yeah, I have a couple from the chat window if you want me to go ahead and filter them to you. One quick question.
Don, I would say if you could just read the questions and,
yep, sure, no problem.
One of us can answer them.
Yeah, sure. So quick question, does Bridges-2 support Ubuntu virtual machines? Thank you very much.
So Bridges-1 and 2 absolutely support virtual machines. When I mentioned and long as I have a screen share still alive, let me go back up here. So the whole point of a lot of these nodes, like the web server nodes, the database nodes, these are explicitly to host virtual machines for different purposes. And we've been doing that on Bridges-1, and this is for persistent things like web science gateways and web portals. We'll definitely do that on Bridges-2 as well. We also expect to be able to launch lighter weight virtual machines on demand. And that I think is key for users to be able to start VMs as they need them. And that can be for putting containers or just for the VM itself. So the answer is yes.
Okay, great. Next question would be, I have an account on Bridges when leading a capstone project at CMU. Is a supplement or startup RAS needed to work with an international university?
Ken, I'll give that to you.
Yes, we're going to have some allocation or an award in place for that. So to work with an international group, it's going to have to be a lead researcher from a U.S. institution. So assuming you at CMU, you would be the lead and you collaborate with this international group. If you have any more questions than that, I'm happy to chat with you offline. We can work through this and get you set up correctly.
Great.
Thanks. And then following to that, this is probably for Ken again, can a supplement be requested for an education allocation?
Yes, they will be able to be supplemented or submitted, just like you would have prior to this. Again, maybe I wasn't clear. I was leaning towards mostly to research and startups, but educationals as well. So go ahead and submit the supplement. We'll work with you on that. We're here to help everyone.
And I'd like to follow up on that. For those who are new to the Exceed or new to the system, what we refer to these different kinds of allocations, startup are designed to be very quick, lightweight allocations. We typically turn those around in about a business day. They require just a paragraph on what you're doing. You can get a fair amount of resources for that. And all of these are, again, zero charge, $0. Research allocations can be much, much larger. Those are reviewed quarterly. Typically, people will use a startup to be able to get some estimation of what they really need, and they use that as justification for the research proposal. Education are available to anyone teaching courses who would like to use these resources for coursework. That can be university courses, community college, even high school courses are using Bridges-1. And so those are also available. Students can get on. A big advantage there is having all of the software and data in a clean environment. So students don't have to install everything and debug it on their own laptops. And those are the main types of allocations.
Right, Nick, let me follow that up. That was a good summary of those. There was a question about what is the maximum fund for an Exceed extract grant. So I'm gonna assume you mean, is there a maximum limit you can request? And that answer is no. If you can justify what you need in your proposal, you've had a startup, you've done your benchmarks, you've prepared a code performance and scaling document, you can request with your justification what you actually will need. Now, there's limits, how much the machine can provide, how much is being requested by other researchers in that particular quarter, and what we've already committed on the machine. But if there are no limits to XRAC or research grants that can be requested.
So I think we have 2 minutes left. If we can quickly go to the poll results, we did promise we'd show these, and we'll show that. If people want to stay on, those of us who stay on can continue. Okay, thank you, Robin. So Robin, would you like to speak to these?
Sure, I can speak to them. Assuming everybody can see this, but the first poll that we asked was we were just trying to get an idea of what kind of users we had attending. So it seems like of those that filled the poll out for us today, 61% of those participating are Exceed users of Bridges. 14% of you are Exceed users of another system. About 19% of you are not Exceed users. So thanks to everybody for helping to give us an idea of the landscape of who's joining us today. And I'll move on to the next one here. So the next poll that we asked you guys to fill out was what parts of Bridges-2 infrastructure that were most relevant for your research. Everybody, this particular poll, folks had the opportunity to fill out more than one. Memory and GPUs were the most popular, the most relevant in this poll, with only being differentiated by 1%, with large memory following up, and then data management at 29%. And we'll make these poll results also available as part of our output from this particular webinar. The third poll, which I accidentally closed a little earlier, so we didn't get as many participants in this one, was asking if any of you incorporate AI, machine learning methods and algorithms within your research. And the overwhelming majority said yes at 47%. Some of you said that you were not currently doing it, but were exploring different opportunities to do that. And then a small proportion of you said that you're currently not using AI, machine learning methods, or algorithms within your research. And then the final poll that we asked was, I'm bringing this up here. There we go. Which of the following AI machine learning frameworks that you prefer? This poll also had a multiple choice option, so you could choose as many as you wanted to. TensorFlow was in the lead with 50% of you choosing that, followed by scikit-learn and PyTorch, and then a few of you said that you're not currently using AI machine learning frameworks in your research, with a couple other selections there. So again, we'll make sure that these are available as part of the output that we provide on our website next week. We'll make sure that we have recordings available next week, along with the slides and these polling results and any other resources that we shared today on our website, probably Monday 1st. Nick, I think you're still muted.
Thank you. Thank you, Robin. So I'd like to note that we are at the top of the hour. So if people need to leave, we fully understand that. But if people would like to stick around for more questions, I'm certainly free. I can stick around till we are all exhausted. So Sean, do we have anything else that has come up?
Oh yeah. Yes.
Well,
So
if I may suggest, so so there are a lot of great questions. I think we should spend a little bit more time addressing some of them, but also I think we will make sure to add them all to slide on also the Q&A of the project on the project website with the corresponding answers, so people can consult there if they have to leave at this time.
That's a great point. One thing we really do want to do with Bridges-2 is to build a knowledge base so people can consult for prior questions. And this set is going to seed that. So we will absolutely make sure all of these are answered in writing, including those we're answering verbally here.
okay. You want me to proceed?
Sure.
Sure. So the next question was, Paula mentioned there will be a data set available on, there will be data sets available on Bridges. Just wondering where I can find popular data sets such as ImageNet. Will there be a public absolute path that all data sets will be hosted?
Absolutely. So currently we already have ImageNet and Bridges. So if the person asking is needing to use it right now, they can, and if they have an allocation or access to Bridges, they can already leverage it. Bridges-2 will also offer these kind of popular data sets for computer vision and text processing. We have for Bridges, we have a data catalog that is currently available on the website. Bridges-2 will feature a similar data catalog that describes each data set and also gives instructions in terms of how to get access to it.
Great. Okay, so the next question would be, is there going to be any, do we have any intention of making a Slack channel for people to interact and discuss things about Bridges-2?
That's a great idea.
Yeah.
I'll take that as yes. There
That
will
is a
be.
yes. We have that. We now have that intention.
Okay, great. Next question was, is this the final hardware configuration? I'll send that to Nick.
Not necessarily. It's our plan of record for right now. As I said, the COVID-19 comes with both challenges and opportunities. And given that there are disruptions in supply chains, we're looking at places where we may be able to do better because of any changes. So this is our plan for today. I guarantee it won't get any worse. It may get better.
Okay, I think that's all the easy questions to answer, or I think the other questions that we have on the Slido in the chat would be better served for us to answer them offline and give people feedback. You check back to our landing page with those questions. So thanks everybody for all the questions.
Yep, sounds good. Thank you. Thanks for everyone for attending.
Thank you.
Thank you.
Okay.
Bye-bye.
Thank you all.
Goodbye, all.
Thank you, guys.
Look forward to having you on Bridges-2.
Absolutely.
Thank you. Congratulations.
Thank you.
Bye.
Thank you.
Thank you all.